Hi there. For this video, we'll be showing more examples on how to solve systems of linear equations using the substitution method. So first, recall that the substitution method is done by representing one of the variables first in terms of the other by using one of the equations. To understand this better, let's recall the examples in a previous video. So in here we have 3x plus y equals 15 and x plus 2y equals 10. So what we did here is we first focused on one of the equations. In this case, we focused on the second equation and we tried to express one of its variables in terms of the other. In this case, we'll be expressing x in terms of y. So what we can do is we can first move 2y to the right to obtain x equals 10 minus 2y. We then denote this as equation star. Now that we have this one, we'll use this obtained value and substitute it to the other equation that we hadn't used, which in this case, this one. So we'll plug this in out here. So plugging in equation star to the first equation will give us 3 times 10 minus 2y plus y equals 15. And in here, we just simplify this one and solve for y. So starting with distributing 3 in the expression 10 minus 2y will give us 30 minus 6y plus y equals 15. Then, adding negative 6y plus y, and we obtain 30 minus 5y equals 15. Move 30 to the right side, and we get negative 5y equals negative 15. Lastly, we divide negative 5 both sides to get y equals 3. So we have now obtain the value for y. From this, what we can do is we plug this value into either the first equation or the second equation. But the best equation to plug it into is this equation star, since x is already isolated. So we'll do that one. So we have plug in y to the equation star and we'll get x equals 10 minus 2 times 3, or when simplified is 10 minus 6 or 4. So we have x equals 4. So we now have a value for x and y. Using these two, and we obtain the solution, which is the 0.43 for this linear system. And so that is how we apply the substitution method. From here, let's now try out more examples applying it. Let's have this first example. In here, we have x plus 3y equals negative 2 and 2x plus 6y equals 2. Before we start this one, feel free to pause the video so that you can try this one first on your own. Okay, so let's start. So again, what we do is we first focus our attention on one of the equations. In this case, let's first focus on this equation out here. And let's try to express one of its variables. Say, let's use x. Let's express x in terms of y. So what we'll do here is we'll just move 3y to the right to get x equals negative 3y minus 2. We denote this by star. From then, we use this value and plug it into the second equation. So we plug into this x out here to obtain 2 times negative 3y minus 2 plus 6y equals 2. We then solve for y out here. So starting with distributing 2, we'll obtain negative 6y minus 4 plus 6y equals 2. Since we have negative 6y and y, we can cancel that one out, and we'll be left with negative 4 equals 2. So from here, what can we observe? Well, we know that negative 4 equals 2 is not true. So we have a contradiction since negative 4 is not equal to 2. What this means is that whatever values of x and y we get, we'll still end up with this one, which means that we'll still have an invalid outcome regardless of any x and y we get. This means that the answer for this linear system is no solution. And indeed, if we show its graph, these two lines are actually parallel, which means that they would never intersect one another at any given point. Or in other words, they won't have any solution. Since, again, when we refer to a solution of a linear system, this refers to the point of intersection of the two equations. But in this case, there is none. So indeed the answer is no solution. So I hope you got that one right. Let's now move to the second example. In here we have 8x plus 3y equals negative 3 and 2x plus y equals 1. Again, feel free to pause the video so that you may try this one first on your own. Okay, let's start. So like with what we did earlier in our previous examples, we start by focusing on one of the equations, and this time let's try to focus on this second equation, and let's express y in terms of 2x. So to do that, we'll simply move 2x to the right out here to get y equals 1 minus 2x, and we denote this as equation star. From then, we use this obtained value and plug it in to this equation. So we'll have here 8x plus 3y, here, the y out here. So that will give us 8x plus 3 times 1 minus 2x equals negative 3. We then solve for x out here. So let's start by distributing 3 to the expression inside to obtain 8x plus 3 minus 6x equals negative 3. Then, since we have 8x and 6x out here, we can add that one to get 2x plus 3 equals negative 3. Move 3 to the right and we get 2x equals negative 6. Lastly, we divide 2 both sides to get x equals negative 3. So we now have a value for x. We then use this and plug it into, again, the best option is the equation star since y is already isolated. So we'll have plugging in x to equation star would give us y equals 1 minus 2 times negative 3, which is equal to 1 plus 6, or when simplified is 7. So we have y equals 7. So we now have a value for x and for y. Using these two, we can conclude that the solution for this linear system is the point negative 3, 7. There should be a negative 3 out here. So let's just move this one out here. And indeed, if we check out its graph, so let's fix this one again. Apologies for that mistake. There. So the solution for this one is negative 3, 7, and indeed if we check out its graph, their point of intersection is at this point, although it's quite small and not noticeable that much. the point out here is -3. So indeed, we got the correct answer. So I hope you got that one right. Let's now move to the last example. So in here we have x minus 3y equals 6 and y minus 1/3x equals -2. Again, feel free to pause the video so that you can work on this one first on your own. Okay, so let's start. So again, we first focus our attention on one of the equations. And if you focused on the equation that I don't choose, that's fine as long as you get the same answer. So let's try to focus on this first equation and express x in terms of y. So what we'll do is we'll just be moving this one to the right to get x equals 3y plus 6, and we denote this as equation star. From this one, we plug this value of x out here. So we'll have this, and that will give us y minus 1/3 times 3y plus 6 equals -2. From here, we distribute -1/3 inside. So what happens here is that we'll have -3/3y plus, we'll have minus instead. So we have -6/3. And this simplifies to -y, and this one is -2. So we'll have this one, y minus y minus 2 equals -2. Since we have y minus y out here, we can subtract that one to obtain -2 equals -2. So as you can see, the y variable was also eliminated, or was also gone now. So what does this mean? So this is quite similar to our first example, but this time we know that -2 equals -2 is valid and is always true, which means that for any value of x and y that we plug in, we'll still end up with an equation that is valid or always true. This means that the answer for this system of linear equation is infinitely many solutions, since regardless of the x and y that we plug in, these two lines will intersect as shown out here, since they have an equation that is always true. So the answer is infinitely many solutions. And indeed, if we check out its graph, we can see here that these two lines actually overlap. Although it's not quite noticeable in this one, since it's just like one line out here. These two lines actually just overlap. And you can see that in the equations, since if you try to manipulate one of these equations like this one, we can multiply out here -3. So we multiply -3 both sides, that would give us -3y plus x equals 6, which is similar or actually just the same as this one. And so that is the answer for this third one. I hope you got that one right. To formally end this, here's a challenge that I present to you. Although we only focused on systems of linear equations in 2 variables, this time we have 3 variables out here. But with a simple trick and simple observation, you can make this one just like a system of linear equation in 2 variables. So as a hint, you can start and focus first on this third equation out here. From then, you can use the obtained one out here to make these 2 equations above it to be just a system of linear equation in 2 variables. So yeah, that's it. I hope you learned a lot from this one. Feel free to comment down below any comments, suggestions, and recommendations that you have for this video and this channel in general. So yeah, that's it, and that is all for this video.